Where to begin? Where to begin? It seems like what I want to do right now is pretty simple. I just basically want to take these numbers and put them up here. And in fact, it's simple. The small amount of code that I need to add in order to do that doesn't look like much. I could put it in right now if you wanted to see it. But that little addition, the creation of what's called a constructor, leads to, it's kind of like that stack frame thing. It leads to a kind of chain of events. In this case, not a chain of events, but a chain of ideas that need to be understood and learned properly in order for you to use this constructor thing properly. That really, before doing so, I should go over several other important facts first. Maybe what I can do, check this in. If I change this to CPP, that's just source control complaining. Then I can do little experiments here in the CPP context to kind of give you an idea of some of the issues involved in this change. Now, these are some rules that I started writing down about constructors, and I'll get to those later, and the reasons for them. I haven't even said what a constructor is. I know you guys are internet savvy, and there are plenty other tutorials, and usually they're covering this topic by lesson 2. But I'm wary about introducing the constructor and destructor that goes with it without some warnings and some information about more information that you're going to need in order to not use them incorrectly. I would say that if you were going to make a mistake programming in C++, your very first mistake will occur within a constructor, almost guaranteed. And the reasons are subtle. They're not obvious at all. And there's a lot going on behind the scenes that you don't realize till much later on. But let me just point something out anyway. First off, of some interest. Everybody in the world who knows anything about C or C++ or anything knows the following. I'm going to initialize a bunch of integers. How many do I want? JKLM. That seems like a lot. Oops. I want to give them different names. We could make an array, I guess. Equals 7. One more. N-O-P. Everybody you talk to, ask anybody in the world who knows anything about programming, thinks they do, N-O-P, can tell you immediately what the outcome of this expression would be. And you probably know too. For instance, if I asked you, what will the value of I be after completing this expression? What would your answer be? And I think that you've probably by now said it's going to be 0. Similarly for J, K, L, M, N, O, P, and so on. True? Okay, well, let's just make sure that it is true. Okay, I want to start here. Now here are our ints. Great big list. Now initialize. I wish this wasn't here, but I know how to get rid of it. Oh wait. Now it should look nicer. Okay. Oh, form. Good God. I tried to get rid of it. There, this is better. Okay, now if I just step over this line, they're all 0. Second question for your pop quiz. You're going for a job interview. In which order are these numbers set? Which one becomes 0 first? They all became 0. They must have became 0 in a particular order. And I think you probably will guess the answer to that correctly as well. And I'll give you a second to guess before I line it up. And we'll see. And the only way to actually see it is to disassemble. Go back to this window. And to actually walk through it one step at a time. You know, most people would say that the last one will be 0 first, and then this one, and so on all the way down to I. And they would be, in fact, correct. P, O, N. I wish they would list them in alphabetical order. L, K, oh, they're listed here, J, and I. Now, actually, this is quite interesting just on its own. You'll notice the way that this is worked. The first is just setting a variable to 0, P, I suppose. And then it goes through this cycle. It goes AX, CX, DX. And when I was doing this before, I noticed it used AX, CX, and DX. And then I was on the last one, and I wondered, well, it's going to run out of registers eventually, and something's got to repeat. So I added more, and that turns out to be the cycle of 3. It goes ACD, ACD, A, and then it would repeat ACD, ACD over and over again. Okay, well, there's not very much to that, really, you would think. Now, remember we'll grab our struct here, not as a class, but just as a simple struct. And I want to use this for the following demonstration. First, I want to make two functions. One returning an int, uh, 7, say, and another function which returns one of these things. Now this is another thing about C++ that's different from C, is that you can return objects of arbitrary size. You remember in C, all this thing's job to do is to get 7 into the AX register. In C++, in fact, there's a similar analog. The way that this return occurs is on the stack of the caller, and in fact, by the end of the call, something is placed in the AX register, and it points at the returned object, which is on the caller's stack. But I won't show that in great detail. Just create a myrect. Doesn't matter what numbers. Okay, and I'm going to return it. Now that's legal in C++. Now I'm going to get rid of all this. That can be whatever. Remain as it was. Now first off, I can say I equals foo1. That's fair enough, right? Should compile. Now we're done. All right. Okay. Now I'm going to try this. Well, let me try this first. This should fail. And the reason that's given is that an L value is required. And the reason why we're getting that error is not because this statement is unsolvable. It's because of the way that assignment works. That is, this assignment is what occurs first, as we just saw demonstrated, and that is not allowed. However, it is a fact about the C language that the result of an assignment, such as this, returns an L value. In fact, it returned this expression evaluates to I following the assignment. So this expression should compile. And it does. And the answer will be I equals 0 in the end, even though temporarily it will be 7. First I'll just step over it. You can see I is 0. And now if I do it slowly, okay, now we call the function that returns 7 in AX. That gets transferred into I. Okay, and now the next assignment is to assign what this expression evaluates to, which is a reference to I, the value 0. And that's done. In fact, I could do it again. But again, I'm going to get the same problem unless I put another set of brackets. So in order for this sort of thing to work, I've got to do the assignments in a different order. I can't assign the 0 to this and then that result to this, and so on. I've got to let I become some weirdo value, which in the end finally gets assigned the value 0. Now I want to look at this foo2. Now, syntactically, this is an identical function to foo1. It returns an object, not a reference pointer or anything. And it's just a function that returns an object. So I could say r equals foo2. That's valid. Okay? Now, according to our previous experiment, that should not be allowed. But hang on, let me just, instead of, well, I haven't defined the constructor part yet, but this should not be allowed, you would think. But in fact it is. It is allowed. And the result of this will be, R will be equal to this 1, 2, 4, 6. Now the reason why I'm showing you this okay, now again the question arises, how did the assignment occur? Was foo2 the function assigned the value of itself? Well, that seems crazy. At least that can't be what's happened. What's happened is some area on the stack, some space on the stack was allocated by this function to hold a rect value, and that rect value was returned by foo2. Now, that being basically a pointer to a piece of memory is assignable to another rect value, and so this assignment is allowed. And in fact, if you follow it through, the assignment goes in the same way as the first example with all those ints, this direction. I don't need to do this in this case and change the order of the assignments. It goes in the same order as you would have expected. Now, what a constructor is a function, essentially, which has the name of the class, and you can make for example, you could have one that takes 4 values, int, and in that function I can set the values like that. Okay, and typically there'll be at least one that doesn't do anything. Usually best not to do any initializing That way you'll see when your variables are not initialized. In that case, I can change this function foo2 to return a myrect and make it look quite a bit more like this foo. Okay, and again, this oops, if you spell bottom right, it would compile. Okay. Now, in the end, I might want to set this to this type of rect, and now it's looking a little bit like the original example, and our guess should be that the value of r in the end should be all zeros. Let's see if it's true. Well, I'm just going to step over, and it is all zeros. But without this line, it should be one of these foo2s will survive, and we get 1, 2, 4, 6. Okay. Now, this here function is called a constructor. It is used to construct the object using some passing parameters. What goes along with a constructor is a function that gets called when an object is not being constructed but is going away, is dying. It's called a destructor. Takes no arguments ever. It's declared like this. Okay. It's not doing anything, but I could, in theory, maybe print something out. Now, the question is, how many times will this function get entered, or this function, and this function? How many times will these get called in the given situation as it stands? Okay. Remember that here a construction is occurring. However, in order to allocate some space on the stack here to copy this return value, another one of these things, possibly using this function, will be called. And whenever one of these things dies, one of these functions will be called. Okay? And when you start dealing with constructors and destructors and so on, this is the sort of problem you've got to worry about, is do all these things match? And in fact, you're going to find that in this case, they won't. I don't think so. Because there's something missing. And that thing always has to be here as a part of this set. But I can't tell you about what that thing is until I tell you about another new concept called a reference. So what I'd like to do, so that we can make sense of what is actually going on here, is talk a little bit about this reference idea, add the missing function, show you why it's required, and then we can talk about constructors and destructors and the rules with which you should use constructors. This sort of thing is okay. We're only setting a couple of values. In general, one should be particularly careful about what one does inside of one of these functions. Either this one, which is sort of a cleanup area, or one of these ones where things are initialized. It's important to know what sorts of things are generally appropriate to put in here. And like I said, I have a little list of things that you should never do in a constructor. Never say never. You can do those things. Maybe there are cases when it's appropriate, but in general, those general rules I'd like to get through before just throwing out this constructor thing as if it's just a regular old function. It's not. It's an integral part of the language, and it's involved in this sequence. Okay, and these kinds of sequences are the kinds of things that occur in function calls and function returns and so on. And so rather than just tell you something and have you use it wrongly, I'd rather take the extra time to explain some more of the background that we didn't cover really, kind of glossed over C, and we didn't completely finish all of the stuff that I wanted to do before getting to C++. It would have provided the necessary background for you to understand why I'm taking a pause here. Okay, so really I've said nothing yet. In the next one, I'll go a little more deeply into this. All right. Okay, see you then.